The restoration begins with the gas welding process, one of the most important steps in repairing a cracked aluminum carburetor. Before welding, the damaged area is thoroughly cleaned to remove grease, carbon deposits, fuel residue, and oxidation that could weaken the repair. Using a grinder, the crack is carefully opened into a V-shaped groove to allow deep penetration of the filler metal. The oxygen and acetylene cylinders are checked, the torch is adjusted to produce a neutral flame, and the carburetor is slowly preheated to prevent thermal shock and reduce the risk of additional cracks. Once the aluminum reaches the correct temperature, the mechanic begins gas welding by carefully melting the edges of the crack while feeding an aluminum filler rod into the weld pool. The torch is moved steadily to ensure even heat distribution and a strong bond without overheating the casting. Extra filler metal is added to rebuild the damaged mounting flange so it can later be ground back to its original shape. Throughout the process, heat is carefully controlled to avoid distortion, warping, or damage to nearby fuel passages and threaded holes. After the welding is complete, the carburetor is left to cool naturally, allowing the aluminum to relieve internal stresses and produce a stronger, more durable repair. The finished weld is then inspected for full penetration, smooth appearance, and the absence of cracks or porosity, creating a solid foundation for the grinding, machining, and final restoration stages. Gas welding also provides smooth and deep weld penetration. During the repair process, the flame gradually melts both sides of the prepared crack while the aluminum filler rod flows naturally into the molten weld pool. This creates a strong metallurgical bond between the original casting and the new filler metal. Because the weld penetrates deeply into the crack, the repaired section becomes much stronger than a simple surface repair. Deep penetration is especially important for carburetors because they experience constant engine vibration, temperature changes, and mechanical stress during operation. One of the reasons experienced mechanics prefer gas welding is its ability to rebuild missing material. Cracked carburetors often have broken mounting ears, damaged flanges, or chipped edges. Gas welding allows the mechanic to add fresh aluminum exactly where material has been lost. Layer by layer, the damaged section is rebuilt until it exceeds the original size. Later, grinders and files remove the excess material to restore the exact factory dimensions. This rebuilding capability makes gas welding an excellent choice for restoring old carburetors that would otherwise be thrown away. Gas welding also places less thermal stress on the aluminum casting compared to rapid heating methods. Sudden heating and cooling can create internal stresses that may lead to additional cracking after the repair is completed. Since gas welding heats the metal slowly and allows gradual cooling afterward, these internal stresses are greatly reduced. The repaired casting remains stable, making the repair more reliable and longer-lasting. Gas welding is also highly effective for repairing vintage and classic carburetors. Many older carburetors are no longer manufactured, making replacement parts expensive or impossible to find. Restoring the original component preserves authenticity while saving complete and the carburetor has cooled naturally. The restoration moves to the grinding stage. This step is essential because the welded area contains excess filler metal that must be carefully shaped back to its original form. Grinding is not simply about making the surface look better. It restores the correct dimensions, ensures proper fitment, and prepares the carburetor for final assembly. A skilled mechanic knows that removing too much material can weaken the repair, while removing too little can prevent the carburetor from sealing correctly. For this reason, every movement of the grinder is slow, controlled, and precise. The mechanic begins by selecting the correct grinding wheel designed for aluminum. Before switching on the grinder, the tool is inspected to ensure the grinding disc is secure and free from damage. Safety equipment, including safety glasses, gloves, hearing protection, and a face shield, is worn to protect against sparks, metal particles, and grinding dust. The carburetor is firmly clamped to the workbench so it cannot move during the operation. Grinding starts by removing the highest points of the weld bead. The grinder is held at a shallow angle, allowing it to remove only small amounts of material at a time. Instead of forcing the tool into the metal, the mechanic lets the grinding wheel do the work. Gentle pressure prevents overheating and helps maintain the strength of the welded repair. The grinder moves continuously across the surface to avoid creating low spots or uneven areas. As the excess weld is gradually removed, the repaired section begins to match the original shape of the carburetor casting. The mechanic frequently stops to inspect the surface from different angles, comparing it with the undamaged areas. This careful inspection ensures that the repaired section blends naturally with the factory casting. Thanks for watching. If you enjoyed this workshop restoration, don't forget to like, share, and subscribe for more heavy-duty machining, welding, and restoration videos. See you in the next project.